Hello learners, welcome again. I'm teacher Anis. We are still looking at Form 3 Chemistry Chapter 2. The topic is the mole, and we have previously looked at introduced what is titration. So we look at the apparatus required during a titration, what is titration, volumetric analysis, and we mentioned that there are three types of titration. One, that is uh, the direct titration, back titration, and redox titration. And so for today, we are going to look at the direct titration. So this one will be our part 10, and we start by defining what is direct titration. So direct titration is a common and straightforward method used to determine the concentration of an unknown solution by directly reacting it with a titrant of known concentration. So remember, we said in titration we usually have two solutions. The first one is the standard solution. This is what we are calling the analyte. This is what we have. The solution, we know its volume and also its concentration. So we react the unknown solution by just directly adding the titrant or the standard solution, or that is the solution of known concentration. Then this process takes several key steps and principles. So we need to consider few steps. So the first step, we call it preparation. How do we prepare for a direct titration? So one thing we need to consider during preparation is that we have to clean the apparatus thoroughly. This is using clean water. So these apparatus are like the burette, the conical flasks, and the pipettes. So we clean them first. It doesn't matter whether the other person who used them had cleaned them. So before you perform your own titration, clean your apparatus thoroughly with clean water. Second, still for in the preparation, you rinse the bullet with the titrant solution to avoid contamination. So you have to rinse the burette. Remember, the burette, you are rinsing it with what? The titrant or the standard solution. Then rinse the pipette using the analyte. So analyte, we say that is the solution which you do not know its concentration. So we are determining its concentration. So you rinse the pipette using the analyte solution. Number two, or step number two, we measure the analyte. How do we measure the analyte? So we use a pipette filler to add the analyte to the pipette. Then we transfer this analyte or this solution to what? To the conical flask. Then add few drops of an appropriate indicators to the analyte. 2-3 drops are enough. Step number 3 is now the titration itself. So you fill the burette with the titrant solution. So be keen so that you don't do it vice versa. So whatever we are putting in the burette is what? Is the titrant. So we add the titrant into the burette and then record the initial volume. Remember, in our titration table, we had to fill for the first, second, and third experiments or titrations. We have to record the initial and final volume. So we have to start by recording the initial volume. So then the next thing you do is to gradually add the titrant solution. We said gradually means small bits or slowly. Swirling the conical flask, so moving the conical flask slowly as we observe. So do not just swirl and forget to observe the color change of the indicator. Remember, we added the indicator to the solution or to the analyte solution in the conical flask. So as we swirl, we need to be checking on the what? On the color change of the what? Of the indicator. Okay, that is step number 3. Step number 4 is what we call the endpoint determination. So the endpoint is reached when the indicator changes its color permanently, so indicating that the reaction is complete. So when you see a permanent change in color in the indicator or in the conical flask, this will tell us that the reaction is complete. So now we can record the final volume of the titrant in the burette. So now we can read from the burette the final volume. So now, so that we can get the volume used, we just subtract the final volume minus the initial volume. Then now the last step is calculation. We calculate the volume of the titrant used. Then we use the known concentration of the titrant and the volume used to determine the concentration of the analyte. So this is how we perform. This is one way in which titration is helpful. We can determine the concentration of a known what? Of a known solution. Okay, let's look at examples. We have example 1, where we are titrating hydrochloric acid using sodium hydroxide solution. So here we are required to determine the concentration of hydrochloric acid using a standard solution, that is sodium hydroxide. So we know the volume and the concentration of sodium hydroxide. So the reaction that will take place it shall be between hydrochloric acid and sodium hydroxide to give us sodium chloride and water. So step number 1, we said it is preparation. So we first rinse the burette with the sodium hydroxide solution. So the concentration of sodium hydroxide is 0.1 molar. So we rinse, then we fill the burette with sodium hydroxide, and we write the initial volume in our table. Step number 2 is now to measure the analyte. Then remember, we have cleaned or we have rinsed our pipette using the analyte. Then we pipette 25 milliliters of what? Hydrochloric solution. This is our analyte into the conical flask. Then we add 2 to 3 drops of phenolphthalein indicator to the flask. That is our indicator that we are going to use. This is a strong base and a strong acid. So we can use an indicator. So for this case, we use phenolphthalein. Then we know that phenolphthalein turns pink in a basic solution. So that must be somewhere behind our mind, and is colorless in acidic solution. So now when we add 2 or 3 drops of phenolphthalein indicator in hydrochloric acid, it will be colorless. But now after we titrate with sodium hydroxide, it will be basic. So that we expect the phenolphthalein indicator to do what? To change its color from colorless to pink. So after we see the pink color of the phenolphthalein indicator, that will have marked the what? The end point of our titration, and now we can read the what? The final volume. So step number 3 is titration. We are told slowly add sodium hydroxide from a burette, okay, to HCl solution. Swirling the flask, we say we must be swirling so that this reaction can take place. Then as we observe the color change, so we say that it will change from colorless to what? To pink. Right. Step number 4, the endpoint determination. So this is what we do. The endpoint is when the faint pink color persists. So if you see that the color is not changing, the pink color that is formed is not changing, and now we can record the final volume of the sodium hydroxide. We read it from the burette. Now, for my experiment, my final reading was 24.50 in this. Then the initial volume was 0.00. That is for the first experiment, and I kept filling the burette up to 0.00 mark. So for the average volume used was 24.50. Now, I can calculate the number of moles of sodium hydroxide used using the formula moles, number of moles is equals to molarity times volume in liters. So I had my molarity of sodium hydroxide was 0.1 and the volume was what? Volume used is 24.5. Then convert it to liters, divide by 1000. So this will give me 0.00245 moles. Now I have the number of moles of what? Of sodium hydroxide. But what I need is the concentration of hydrochloric acid. So I need now to get the number of moles of hydrochloric acid. From the reaction, we saw that the ratio between hydrochloric acid and sodium hydroxide was 1:1, meaning the number of sodium hydroxide is equal to the number of moles of hydrochloric acid. So the number of moles of hydrochloric acid will also be what? 0.00245 moles. Okay, then now we can get the concentration. So the concentration of hydrochloric acid, remember the formula of getting concentration is equals to moles divided by volume. So, and it is volume in liters. So we have the moles as 0.00245 moles divided by the volume in liters. That is, remember we added 25 centimeters cubed of what? Or 25 ml of the hydrochloric acid as the analyte. So that is the volume of HCl. It will be 25 of 1000 and the concentration will therefore be 0.098 molar. So it is that simple to determine the concentration of the analyte using titration. Right. So let us look at another example. We are titrating acetic acid using sodium hydroxide. So we are determining now the concentration of acetic acid. So this is the reaction. Acetic acid is an alkanoic acid, so CH3COOH plus sodium hydroxide. That would give us sodium ethanoate plus what? Plus water. So the first step, we said preparation, rinse the burette, that is always the first step. And our standard solution, which is sodium hydroxide, is still 0.1 molar. Then we fill the burette with sodium hydroxide solution and then record the initial volume. So initial burette reading. Then measure the analyte. So we always pipette 25 ml or 25 centimeters cubed of the acetic acid solution into a conical flask. Then add the drops of phenolphthalein indicator, right? Then the next one is to titrate. We slowly add sodium hydroxide that is inside the burette. It is our titrant to the acetic acid solution as we swirl. Don't forget to swirl. Then observe the color change. So the color change will be from colorless to pink. That is the color change of phenolphthalein indicator. Step number 4 is the endpoint determination. So when the faint color persists, it is not changing for some few seconds, we record the final volume. So the final volume of sodium hydroxide in the burette, we record. So we repeat this experiment for two more experiments to get at least 3 final volume used of the what? Volume used of in this reaction. So for my case, the average volume was 20.00 milliliters. So I was required now to get the moles of sodium hydroxide. I had its molarity 0.1 times its volume in liters is the volume used. So what we have calculated from the table to give me 0.002 moles. Then remember the reaction, the mole ratio between acetic acid and sodium hydroxide was 1:1. So meaning the number of moles of acetic acid is equal to the number of moles of sodium hydroxide. So we want to get the concentration of the acetic acid. We have its volume. We pipetted, that is 25 ml. In liters, it is 0.025 liters. Then we have its number of moles is 0.002 moles. So to get its concentration, we say it is number of moles over volume, which would give us 0.08 molar. So that is the concentration of what? The concentration of the acetic acid. Okay, so that marks the end of part 10, and we are going to look at more examples in part 11. So see you again in the next video.